Let's do a review of some basic function types. So something we should be familiar with. Okay, so let's look at lines. Then after we get done with lines, we'll do some other things. But let's just check out lines first. So look at xy axis. And let's just let this be a generic line. Okay. So the equation for a line can be written as y equals mx plus b unless the line is vertical, right? So if the line is vertical, let me just draw a vertical one. Why can't I write this as y equals mx plus b? It's because what does the slope mean? So, normally m stands for the slope, and b stands for where it touches the y-axis, right? Which the fancy word for that is the y-intercept. But if you have a vertical line, it doesn't have a slope. Its slope is kind of infinity, and also it doesn't have a y-intercept. And notice that it's kind of ambiguous as to whether it's going infinitely up in a positive way or infinitely down in a negative way. So vertical lines are just kind of a weird case. If you have a vertical line, the way to write an equation for a vertical line actually doesn't involve y at all. So if this is a vertical line that goes through 3, then the equation for that vertical line is just x equals 3. Okay, and so notice that this does describe the set of points on this line, right? So this line, this vertical line, consists of and exactly of those points that have 3 as their first coordinate. It's like 3 and then whatever you want in the second place, right? And so that's exactly what x equals 3, the equation, is expressing. So it's describing this subset of the plane. Alright, so I didn't mean to go in a big digression about vertical lines, but that's the way vertical lines work. So a typical line is y equals mx plus b, and so m is the slope, x is the free variable, and b is the y-intercept. So let's just look at an example. Just make up an equation for a line. Say y is equal to 7x minus 2, and I want to graph it. So let's graph that equation. Alright, so how do I start doing this? Well, I know that the y-intercept is negative 2, right? So there's several ways to go forward. One thing I could do is just kind of guess what a slope of 7 looks like. So I know that it's going to cross the y-axis here, and the slope is going to be 7, so that's extremely steep. I can draw a slightly better picture if I figure out the x-intercept too. So the x-intercept is the place where it crosses the x-axis. So how can I figure out what the x-intercept is? So you should think the x-intercept happens where the y-coordinate is 0, right? So at the x-axis, for every point on the x-axis, the y-coordinate is 0. So how do I look at the x's that make this equation true along the x-axis? I just plug in y equals 0. Okay, so that will tell me what the x-intercept is. So I can just solve the equation 0, because I plug 0 in for y, is equal to 7x minus 2. Alright. And so I'm not going to go through the algebra. I just know that that's equal to 2 over 7. So let's do solving linear equations later. Alright, so it's 2 over 7, so that's a pretty small number. It's right here. Alright, so now I know 2 points, and 2 points determine a line, right? So the graph of this line is just the line through these 2 points. And there it is. So it goes off infinitely like that. Alright. So there's lots of stuff to know about lines, but I just wanted to the main thing I wanted to say, I mainly wanted to say that lines are described by y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so let's look at a slightly different function. All right, what about the equation y equals 1 over x? So remember what that thing looks like? So the shape of this function is like this. We call it a hyperbola. So there's one part of it there, and then there's another part of it here. Okay, so this is the graph of this. This is the curve described by that equation, and the word for it is a hyperbola. Alright, and so why does it look like this? Let's just kind of roughly try to figure out why it looks like this. So why does it go, you can see that it goes to infinity as the x values get closer and closer to 0. Okay, so why does it do that? Let's just think about putting in, let's see what happens if x is really small. If x is really small, it's like, I don't know, what's a really small number, like 1 over 1,000, right? So what happens if I plug 1 over 1,000 in here? So if I put that in as input, then what I have is 1 over, what I put in for x is 1 over 1,000, so I have 1 over 1,000. And you might remember that this is the same thing as 1,000. Okay? So if you put in, how small could it be? Let's just say that x is equal to 1 over n for a big number n. Who knows what it is? As n gets bigger and bigger, this point here is going to get closer and closer to the origin, right? Because fractions with big denominators get really small. So what happens if I put this in? Remember, here's my formula. So if I put y equals 1 over n for really big n, and here what I'm going to get is 1 over n, and that's going to be the same thing as n. So you can see, as this n goes to infinity, what happens? 1 over n goes to 0, but this thing, the hyperbola, is 1 over n, and it goes to n, right? So as n goes to infinity, the function 1 over x goes to 0. So what am I saying here? So I'm saying that the limit of